borehole data can be imported into Leapfrog Works here from a few different formats, including CSV tables and AGS files using the Import Boreholes option, or directly from a GINT database using the Import Boreholes via ODBC option. In this video, we will use basic CSV tables to demonstrate the considerations and requirements for importing borehole data. Learn about the specifics of importing boreholes from a GINT database or as AGS data in the following videos. When importing any data into Leapfrog, keep in mind that Leapfrog is a unitless program. Leapfrog adopts the units of the data that are imported, like meters or feet, so it is very important to be consistent. The values you see throughout a project, for example, the surface resolution or the distance measured with the ruler, are in the units that were imported. Regardless of its origin, to successfully import borehole data into Leapfrog, you will need caller information, including a hole ID and the XYZ location coordinates, and at least one downhole interval table. If any of the boreholes aren't vertical, you will also require downhole survey information. Click Browse to navigate to the caller file. Leapfrog may automatically select the survey table if available, and certain interval tables, provided they are in the same folder as the caller file and have names that are picked up as keywords by Leapfrog. If not, simply click Browse or Add to search for additional tables. I will also add the RQD USC table. Click Import to bring them in. This opens the Import Borehole window with a preview of the data Leapfrog has read from the caller file. Regardless of the source of the borehole data, be it CSV, AGS data, or data imported from a GINT database, the importing workflow from this point forward is exactly the same, using the same window with the same options. The caller file defines the location of the boreholes at surface and requires at least 4 columns, a hole ID column, and the 3 coordinates, easting, northing, and elevation. We recommend the caller table also has a total depth column, which Leapfrog uses to run some internal validations. As we can see here, these required columns have been selected automatically based on the header of each column and are marked in green. There will likely also be several additional columns in your caller file that won't be automatically selected. When you're importing data into Leapfrog, it is important to identify which columns will be helpful in the modeling process and which ones won't. We recommend only importing columns that will be necessary for modeling and leaving the rest not imported. When importing, less is best. It is easy to add columns later, but once a column is added, it cannot be removed. Importing unnecessary columns at the beginning will require those columns to exist in any reloaded or appended data you wish to add later on. Also, these needless columns may also increase processing time in the project. When carrying out the initial import, consider carefully what you need. Fortunately, it is easy to add additional columns or even whole data tables later if you discover that you need them. This will be covered in a subsequent video. For now, I will choose to import the phase column as a category data type and the date completed column as a date, but leave the rest as not imported. It is possible to choose which encoding you would like Leapfrog to use when importing borehole data. By leaving the auto encoding option selected, Leapfrog will select the most suitable encoding type. If there are international characters in your borehole data, select the character encoding dropdown and find the encoding type that matches your data. You can also change the date and time formats as well as rules for importing CSV characters. Once you're done with the caller table, click Next. The survey file defines the orientation of the boreholes at a given depth. If using a survey table, it must have columns for hole ID, depth, dip, and azimuth, as we see here. If the project only contains vertical boreholes, a survey table is not necessary. Interval table data specifies segments down the borehole with associated values such as lithology codes or RQD values. Interval table files must have columns for hole ID, from and to depth, and 1 or more columns of measurements. Measurements can include geotechnical data, lithology, weathering, or any required numerical or categorical values. In this case, the geology column has been automatically identified as lithology. The import as options are important to fully understand. Lithology and category are used to import any categorical data such as lithology codes, CPT codes, weathering, alteration, etc., and are actually functionally equivalent in Leapfrog, so it doesn't matter which one of these that you pick. Text is used to import columns like summary or description. Such columns are functionally limited within Leapfrog, and columns imported as text cannot be used for modeling. Numeric is used to import any numeric data, such as RQD values, contaminant concentrations, etc., that you would like to model as numeric data. Timestamp and date are used to import time and date information. Custom formats are supported. URL is used to import an associated URL and can be used amongst other things to connect core photos to boreholes in Leapfrog. Lithology is the correct option for this interval table, so I can click Next. The last table to import contains the RQD and UCS data. For now, I will only import the RQD data as numeric using this dropdown. Click Finish to process the import. When you import borehole data, you will likely see a little red X or yellow exclamation mark on the table icons. Leapfrog validates all the imported data and flags any errors it finds. We will cover fixing errors in the next video.